Hello, I'm Dustin Rosseri. Today, me, my friends, and Super Broccoli are here to talk to you about glucosinolates and how they help us stay healthy and strong. First, let's talk about secondary metabolites. Um, they do not have any effect on the growth or development of plants. So how do they help us? Well, let's look at an example first. The red chili pepper, they have capsaicin, and that's what makes them spicy. But what they actually do is reduce molding and bacterial growth for the plant. Secondary metabolites have three major groups and functions: terpenoids, phenols, special nitrogen metabolites. Their major functions include growth regulation, defense, and reproduction. Here, see here with the aphid attacking the stalk of a plant, and reproduction, as we see here with bees being drawn in to the plant for pollination by specific smells. Now let's go a little bit deeper, and let's focus mainly on the nitrogen containing compounds right here. That's pretty much it.
My name is Matthew Phelps, and I'll be presenting the synthesis of the biomolecules. So the synthesis of glucosinolates or any kind of biomolecule is much like an assembly line. As you can see here, you can see all the workers. They're kind of like the enzymes, and they're kind of doing different functions right now. And you can see that they're using different types of substrate to get their job done. So this is the synthesis biopathway that's responsible for making glucosinolates. This looks very, very complicated, and scientists work very, very hard to figure out this pathway. But there's really only three main steps I would like you to remember. And the first one is pretty much just amino acid degradation, amino acid breakdown. And then there is side chain elongation. And then the third and final step is the glucosinolate to the decorated glucosinolate. So basically this helps with storing and recognizing for the cell to recognize the type of glucosinolate it is. And also, once again, you can think of the enzymes, which are represented right here and next to the arrows, as basically the workers that have a responsible mission to make sure that action is carried out. The last, but one of the most important steps, is glucosinolate decoration. So basically all we're doing right now is we're adding little side chains to the glucosinolate. This will help determine function and where it's stored and make sure it's recognizable to the cell.
That's on me.
Alright, so now it's time to break it down now, y'all. So basically glucosinolates follow a series of hydrolysis reactions to reach their desired products. These desired products have specific features which we'll cover later. And basically the R groups, which you see right here, is just the remainder of the molecule. These are things that really do not have to do too much with the actual function or the functional groups of the molecule, or the reaction, but they're still important. So basically this part of the reaction right here is a spontaneous reaction. So spontaneity is important, and that this process doesn't need any further energy to push it over that hill. So the delta G has a negative value. The products of glucosinolate being broken down are isothiocyanate and nitrile. These are the two functional products of glucosinolate.
Hi, I'm Chris Pedersen, and I'm going to be talking about the various applications and impacts of glucosinolates. And so here's our friend Broccoli, and in 2015, Madsen, Kuhner, and Reichert genetically manipulated the different levels and distribution of glucosinolates within the leaves. And so it made it so these aphids weren't preying upon the leaves as much, so it has a higher production value later on. One of the properties of the major degradation product of glucosinolates, isothiocyanate, is a pungent mustard odor. And so this is another quality that makes it so that bugs don't prey on it so much. In 2015, Alzada and Sathe used the pistachio and the glucosinolates within it to inhibit the growth of Aspergillus flavus, which is a toxic microspore. The incorporation of cruciferous vegetables, which is broccolis and spinach and all the different things in the mustard family, if you steam them, then you can incorporate this into a healthy lifestyle with preventative health measures such as proper hygiene and exercise and living a stress-free life. And if you can't do that, then just steam your vegetables. And so furthermore, it's been shown in many different types of prostate, lung, colorectal, and breast cancer to reduce tumor size. And so this is done in my surveys.
So in sum, secondary metabolites need to be modified a little bit before the plant can use those molecules as glucosinolates to help perform a variety of functions that help the plant stay healthy. And some of these functions include antifungal and bacteria functions, and then prevention against some cancers.
Bachelor in biology, so I got a job, and first job in China at that time, that's 30 years ago, there were not too many students graduate from college, not even have many like PhD or master degree. So when student graduate from college and university, you directly can get a job from college. So when I graduated from college and university, so I became like a lecturer assistant teaching botany. So then I feel, okay, that time I want to figure out what I'm going to do. So I realized that the genetics are fundamental part. Then I decided to study my genetics master degree. So when I finished my master degree in genetics, that time I'm really interested in human diseases and stuff. But before I make decision, whether I go to medical science or go to plant science, I look back time my life. As I teach in my class there, I did not see doctor until I was 19 years old. So most of the time we live on the plants. So I was very fascinated to the Chinese medicine. I was trying to figure out why Chinese medicine had so many medicine use. So then I decided. I had two institutes. One is a virus diseases institute, I want to apply in China. There's another is Institute of Botany and Chinese Academy of Science. So finally I decided I should still stick out the plants. So that's why I moved to study my PhD in plant physiology and focus on the plant secular metabolism, which is also called plant natural